So today we're in a shop and we have a 19 DT 5.7 liter, and we're going to show you guys how to go through and break down and diagnose the P1621 fault. It's the reference voltage low code, and what this fault's actually designed for is to detect failures in the return circuit. So as you can see, we have our upstream return circuits tied together and our downstream return circuits are tied together, and a fault or short anywhere in one of these circuits will actually set this code, which is what it's supposed to do. Now we have issues in the field where, when we're going to go back and we're going to show you, and we're going to break this down and show it to you, how a signal circuit shorted can bleed as the sensor warms up through the sensing circuit into the return and also affect and set the return circuit code. And it's leading to some misdiagnosis by technicians, so we're going to show you how to actually determine that and how to break down and figure it out. All of the information we're going to actually show you here on the screen, simplify it for you, is all on service library, as you can see, in the diagnostics. So we have all of this information explained here. It's in more detail if you want to read it. So what we're going to do is we're going to show you first, we're going to go to YTech and we're going to filter on O2, and you'll get a bunch of O2 data, but for this code here we want to sort on the 4 O2 sensors, and we want to bring up the raw voltage data and the bias voltage data with the 2.5 added in. And you can see this one here has 4 narrowband sensors. Now this diagnostic we're going to show you is only for the narrow bands. It does not apply to wide bands. So as you can see, this sensor's cold. Everything's at 5 volts, but we're going to start the engine up. And we're going to watch now. There's no faults in this car right now. So we're going to see how the data, if you see here, the sensors are coming down. So it takes pretty quick, gets warmed up. So we're cycling between 0 and 1 on our wall voltage ranges, and we're also cycling between 2.5 and 3.5 on all of our bias voltage ranges. And what we're going to do is we're going to go now and we're going to put a short in the 1-1 return circuit here on this circuit, and we're going to show you how it affects it. So you can see that it's shorted to ground. Now as you can see, all the bias voltages, all 4 of them are down, cycling between 0 and 1, same as the raw voltage ranges. That's what you would typically see if it was short on any one of the 4 return circuits. Because even though, as you see here, the 2 are tied together, upstream and downstream, internally, as we said, all 4 of these are tied together. So any one of these circuits will affect all 4 of them. Now we're going to go back, we're going to take that short away, we're going to let it go back to normal, and you see it goes back pretty quick. So now we're going to take and we're going to go put a short on the 1-1 signal circuit here, the K41. And we're going to show you how that affects the readings. So what you see is you get 0 volts on the 1-1 sensor, which is the one we shorted. But you see the bias voltage went down and it's switching like it did before, because that short now is leaked into these sensors are warm, it's leaked into the return side, and as you can see the other 4 are all switching 0 to 1. But we know that, because we've done it, is there's a short right here on the 1-1 signal circuit. So when you go to the car and you start trying to diagnose this short to ground code, you're going to be looking at the signal here on this fault, not the 4 return circuits. So it's important to note that. It helps you understand before you get into the car what you're actually trying to diagnose. If you didn't see this and you saw what we had the first time, you'd have to go look at the 4 return circuits and try to diagnose a short in one of those 4. So one other thing I wanted to touch on really quick, just for clarification. What we showed you was on a vehicle that has all narrowband or 4-wire sensors. If you're working on, let's just say we have here a diagram for a 2.4 liter KL. So the 1.4s, 2.4s, and the Hellcat engines that have wideband upstream sensors, you can see that the returns are not tied together. And internally they also are not tied together. So there are separate codes for the return on the widebands. So if you were, in this example, working on a 2.4 liter and you sorted, you would have just the 2 sensors. But you can still use the same principle. If you have the return circuit failure and you pull up the readings and you were looking at them here, this would be your downstream or your narrowband. If you saw zeros on these, then you know the problem is a short on the signal circuit that is bleeding into the return, causing a return fault. If you actually had a short on the return circuit, you would see what you saw before, and both of these values right here would be switching between 0 and 1. So then you would know you'd have to attack the return for the short to ground. So just keep that in mind if you get a wideband vehicle, that they are different and you need to factor that in when you're doing your diagnostics.